The NEET 2021 question from work power energy. Let me read out the problem for you. A particle is released from a height s from the surface of the earth. At a certain height, its kinetic energy is 3 times of potential energy. Then what is the height from the surface of the earth and the speed of the particle at that instant respectively? It's a very simple problem. Let us try to understand what you mean to say, right? This is the earth. Assume this is our earth surface. From the earth's surface at a height s, a particle is released. Release means its initial velocity equal to 0. At a certain height, where it is given that the total height is s. At a certain height, we have to find out that height from the surface of the earth. So for the simplification, I will call that as h, and that h you want to find out. At a particular point, automatically that height will become s minus h. Obviously, it is in the journey, so it will have certain velocity. And so it will have certain potential energy and kinetic energy because it's at a certain height from the ground, right? So what we can say, at a point O, somewhere in the journey, that was given in the problem, I can write potential energy as mg, height of that particle from the earth's surface. That's the potential energy means. So from the earth, we have called that point as h. Kinetic energy is half mv square. I need to calculate this v when its initial velocity equal to 0. So between the points x and O, I can write between the points x and O, I can write a formula v square minus u square equal to 2as. V square I have to find out. Dropped or released, so u square is 0. It's coming down 2g. Sc is height from the top because it has acquired velocity because of falling from that height. That is s minus h. So I know v square equal to 2g of s minus h. That implies I can write kinetic energy as half m in the place of v square 2g of s minus h. It is further given that at point O, that is here, kinetic energy is 3 times of potential energy. I know kinetic energy, I know potential energy, just write in that condition. Kinetic energy is half m v square. What is that v square is equal to? This value, half m v square means I have already calculated as 2g of s minus h. That is kinetic energy is 3 times of potential energy mgh, where h is the height from the earth's surface. So mg is there on both sides, which can be cancelled. This 2 and 2 also can be cancelled. So s minus h equal to 3h. So s equal to 4h. So h equal to s by 4. So this happened at a height of s by 4. So only option that you can eliminate is this because it cannot be s by 2. But to find the other option, to find the correct answer, we also find out speed of the particle at that instant, right? So what we can write at point O, to find out speed, we have already written an equation. What is that? V square equal to 2g of s minus h. We have already derived that. But now I found that h equal to s by 4. I can substitute that. 2g s minus s by 4. That equal to 2g of 3s by 4. That equal to 3gs by 2. 1, 2 can be cancelled. That is v square You want V, so I have to put under the square root. 3gs by 2. So where do you have that? Only here, nowhere else. This is not under the square root. There is no root, so they are not the options. So option number 4 is the answer. So the problem is very simple. It's a very basic conceptual problem. I have simplified the problem by assuming the height from the surface of the earth. Therefore, the point from the top becomes at height s minus h. You can do in reverse also and still solve the problem. Anything is fine. I have used only basic formulas: potential energy, kinetic energy, v square minus e square equal to 2as. Or explanation, everything is simple, right? That's how we come to the answers. V is this much, h is this by 4. That's it. Thank you for watching.